Hi guys, good morning. Today we have another special classroom to attend today, and that is going to be on how to find um the maximum or minimum value of a quadratic function. This is mostly always exams kind of problems that you may see that may possibly come in any of the exams. So, all right. Before we start this class, I would like you to, if you did not do that, subscribe to my channel because it's going to be highly relevant to your learning. All right, so let's kickstart immediately. If you have a function, a quadratic function, f of x equals to a x squared plus bx plus c. This is the standard form of a quadratic function. So the secret of finding the maximum or minimum form of this quadratic function is to write this quadratic function in vertex form. In vertex form. Just to write it in vertex form. Write in vertex form. All right. Now look at it. Vertex form of a quadratic equation look like this. Equals a into x minus h raised to the power of 2, then cancel plus k. That is how it looks like. This is a vertex form of the quadratic form. This is vertex form. All right. So, but before we go into that, let's talk a little about the constant a, the leading coefficient. Now, for you to know whether a parabola is facing up or is closed, we knew that we don't need to solve any problem to know this. You only need to look at your quadratic function or equation to know whether it will turn up or it will turn down. Then there's a whole lot of things to know when those two things happen. Now, this is what I will tell you. If a is greater than 0, the parabola, that's the curve, the parabola will be like this. It will turn up, like this. It will open upward. Now, this is the principle there. If a is greater than 0, it will open upward. And if a is less than 0, the parabola is going to open downward, going to be like this. Now, in these two conditions, where does the vertex form? Now, let me draw the two parabolas now. This is the opening upward and the opening downward. Now, this is the position, the turning point is the point of the vertex where we can get the maximum value or the minimum value. Meaning in this case, so that top there form the max. Now, we still have vertex value, which will be your x and the f of x value at this point. Okay, so this x and f of x value at this point, the collection of both of them is called the vertex values or vertex value of the coordinate of vertex. Just call that vertex. Okay, is always the order pair. All right, where the f can be maximum value or the minimum value. In this case, it will be minimum value, and in this case, it's going to be maximum value. Okay, so how do we get this algebraically? Let's start the main deal. So if you have the f of x to be equals to the function ax squared plus bx plus c, the first thing you do is to factor out the a. I'm going to show you another way of factorizing. So if I do that, I will have x squared plus b over ax plus c over a. All right, so this factorization, I'm simply factoring a out. Since a were not present in the second term and the third term, so they would turn to become the coefficient, the denominator of the coefficient of the x and the constant c. Now, why am I doing this? For you to complete the square, for you to complete the square, you have to make the coefficient of the leading principal x, that is the x square, must always be equals to 1. All right. So at this point, we can complete the square of the term inside the braces here. So we want to complete the square now of the expression in the braces, complete the square. Now, we will have that f of x is equals to a into bracket open. I will take, for you to complete the square, you take half of the coefficient of x and then add more and subtract the same term and okay, of the expression there, and then carry out the simplification. So this will be the coefficient of b is uh, b over a. Half of it is times 1 over 2, and that will give you b over 2a. Now, square this result. This will give you b over 2a all squared. Now, I'm going to add this result to the expression in the bracket. So, but before then, I'm going to separate the x expression from the constant expression with a parenthesis. I will write this like this. X squared plus b over a x, then plus c over a. I've not really done anything. So I want to add and subtract this result here. So I will have f of x equals to a braces open. I will have x squared plus b over a x. Now plus, I'm going to introduce a new stuff there. That would be plus b over 2a, okay, and then square. Then I close the bracket, that's for the internal one. Then plus, we already had a c over a. Then I'm going to say plus, this side, I'm going to subtract because initially we didn't have this term in the expression. So because of that, I'm going to subtract so that it will look as nothing has really happened. So pick up pen. So we have then minus bracket b all over 2a all squared. Now we close the parenthesis. Why did I do this? So you see, if I open this bracket here, because of the plus sign, is not really relevant. If I open this bracket here, plus b all over 2a squared minus b all over 2a squared, this done to be 0 and give back this place. Okay? We are not going to do that. So what we'll be doing right now is we factorize the expression here in the bracket, and I will not stress you. I would like you to look at exactly what I'm going to do right now. So this is equals to f of x. F of x equals a bracket open. And anytime you want to factorize this, just bring the x. Now, since this is with a plus sign, there is a plus sign here. Bring this term, this factor with a plus sign into this new bracket, b over 2a, close the bracket, square everything at once. Trust me, that is a complete factorization of the entire thing. So you have plus c over a minus b squared over 4a squared. You close it. Okay, so now we have that our f of x is equals to a bracket open x plus b over 2a all squared plus c over a minus b squared over 4a squared. All right, so now I'm going to simplify this place, and that will be equals to a into bracket x plus b over 2a, okay, close bracket, and squared, then plus the LCM of 4a squared, and a is going to be 4a squared, then that of this, the other bit is of 4a times c, that will be 4ac minus b squared, close the bracket. Now I'm going to allow the a to come inside. That will be is equals to a into x plus b over 2a or squared, then plus a times 4ac minus b squared divided by 4a squared. Now a here is going to take care of this a here. And then we have that to be a into x plus b over 2a all squared plus 4ac minus b squared all over 4a. All right, so we've gotten the vertex form already. It's just for us to do something. So I would say, um, if you at this point, okay, let's rewrite it out here. So f of x there, I said equals a plus x plus b over 2a all squared, then plus 4ac minus b squared divided by 4a. Now, if you look at it critically, you see it resemble what I wrote earlier. So if I said let minus h equals to this, um, if I say minus h equals to this and k equals to the entire term, because everything here is a constant. So let me start with that one. So I will say let k equals to 4ac minus b squared divided by 4a. So that thing they will become f of x equals to a into x plus b over 2a raised to the power of 2 plus k. Now we see it really appears. So now we've got it. Now, if we let what is inside the bracket here to be equals to 0, so we will have if x plus b over 2a equals to 0, it therefore means that x equals minus b over 2a. So that means this is the value of x at a point where the function f of x is equals to 0. How do I know that? If I substitute the value here, this value of x into this bracket, you will have f of x equals to a into minus b over 2a plus b over 2a close bracket square plus k. And that implies that f of x is equals to 0 times, a times 0, then plus k. So it means that at that point that f of x at the point where x equals to that value, f of x equals to k. So k, which is the maximum or the minimum value. Remember what I said. We can only say that the function will have a maximum or minimum value depending on the value of a. If a is greater than 0, you will have a minimum value of f of x. And then if a is less than 0, then you will have the maximum value of f of x. All right. So that's that for that quadratic function. So if you find this very much interesting, don't fail to subscribe to my channel because it will really help you a long way. So I would like to do one of the illustrative example. For example, if you have 2x squared plus 3x plus 5. All right. So, and you are asked to find the if the function is maximum or minimum. Now, the first thing you look at is the coefficient of A. You see that A equals to 2, B equals to 3, and C equals to 5 from this problem. Now, the A here, which is 2, is greater than 0. From the function, A is equals to 2, and 2 is greater than 0. Therefore, the function here will provide the minimum. The curve will turn this way. So now you can see that if that is the truth, then I can get the value of x at that point where that curve will have that value. So the value of x there is going to be equals to minus b all over 2a, and that will be minus, let's go check out what b is. B equals to 3, so that will be equals to 3 minus 3 all over 2 times 2, that is minus 3 all over 4. So you see that there. So we have that value there, x equals to minus 3 over 4. So if you also check you want to check, let's make this value relative a little bit. Um for the for the value of the max, this minimum value. So with minimum value, you can say, that f of x is going to be minimum, is going to have the minimum value. So, and the minimum value of f of x at the point of x being minus 3 over 4 is going to be equals to the value of k, and k was equals to 4ac minus b squared all over to 4a, but 4a. So then how do we substitute these values into this equation? So in function, we have that will be 4 times a is 2 times c is 5, then minus b squared. B is given as 3. So 3 squared is 9. All right. So all over we have 4 times 2, that is that. So that will give us as 8 times this is 40 minus 9, that is 31. So all over 8. So we have that this will be 31 over 8. 81 over 8. So you can see also that this will be the same thing as 3 whole number 7 all over 8. That is the 24, 13, all right. So we get the value of the minimum value of the function. The minimum value will be 31 over 8, or you can just write it in the mixed fraction as being equals to 3 whole number 7 over 8. So I believe this video really helped you, and that is how to find it. So please don't fail to subscribe to my channel. Thumbs up if the solution makes sense to you, helps you in any way. All right, so at this very point in time, we call it a day. Thank you for your time.